Okay, so plan for here is we're going to go over the dimensionings for parts 9 through 12, and this has a major change in that these are the first parts that have any sort of curved surfaces. And up until this point, we have done our width, height, depth, start on the left. Every time something happens, take a dimension, that sort of thing. And that's still going to be the case for our linear dimensions, but we have curved dimensions also, and they have their own sort of mantra. The mantra for curved dimensions is size and location. Every curved surface is going to have a center point, whether it's an arc or a circle, an arc partial, circle full, enclosed. And you need to size and location. Location is the location of that center point from two directions. Okay, like this center point right here has a this center point is 2 inches from the left. You need to give that information. It's 4 from the bottom. You need to give that information. That's the location of the center point. And then you also need the size. And the key piece of information here is that arcs are dimensioned by their radius, distance from the center point, and circles are dimensioned by their diameter, which this is a symbol for diameter. But luckily, the inventor does that already for you. And if you recall back to when we did the mini train, there were times when it had like TYP written on it, as in like typical. And this is a good time to use that, where something like part 15 has 3 holes that are exactly the same size. You wouldn't need to put a diameter dimension for each one of those. You could just do one and then edit like the text to say TYP. We'll get to that in a second. Okay, either way, remember you are doing yours that fill the screen, fill your sheet, but I'm zooming in, making smaller ones so that you can see the text. And I'm going to make a new sheet in my running list of sheets for the numbers. I'm going to edit this. This is part 9. And let's go ahead and get our base views. And we'll go to part 9. And I'll keep with my 1/4 scale. That, and that. And I do think we are better off with the shaded rather than unshaded. It just is a little clearer. You know, it adds information at very little cost. Okay, so we're going to annotate. First thing you're going to do is get center point, which is this button right here. We haven't used this one right here, center mark, I mean. Click on that, and any curved surface, you're going to click on the curved surface. Okay, there we go, center marks. Okay, those center marks are essentially when we would say like every time something happens, take a dimension, those are that. That is that. Those are things just like edges before. So we need to treat those like that. And then we can do dimension, regular dimension. And on the same curves, we need to take a dimension, just click on the edge of the curve, go out and put it somewhere out to the side. Now, there are like principles like you don't put, this is called a leader line, where before it's called like an extension line. Don't worry about that. Okay, so like on a linear dimension, you have extension lines. These, I believe you'd call them leader lines. You would never have them go like straight out horizontally or straight vertically, because it could be confused or written on top of another line. And the whole point is about avoiding confusion. So if you have it going out at a 45, 30, or 60-degree angle, it's very clear that's not an extension line, because extension lines would always go horizontally or vertically on the sheet. Okay. But we still have the same rules where we don't want it to be like on the view. We don't want it crossing over. Okay. So again, if you're ever not sure, make it neat. And then the same thing over here. We have another arc. We wouldn't want this here because that's on the view. We can put it out here. If you click this dimension and go this way around, it has this weird arc extension line. It takes a little finesse, but if your cursor has to pass through the center line, the center mark out there, in order to get it to look like that, which is what you want. Okay, and now we just go back to our left to right every time something happens, take a dimension. But this does take a little bit more inference, in that because you have to kind of figure out, does the dimension already exist? So if we start on the left and dimension to the center point, which the center mark we created like that, this dimension already exists, because we can see that it is, this radius tells us that the center mark is 2 inches from the edge. So we don't need that one. Okay, then, so still back to the left, next thing that happens is this. Won't even let me get that point. So yeah, there's that too. There to there. Nope, that's not it. Okay, but either way, even if we were dimensioning that point, which surprised it won't, there we go, that point right there. Okay, we don't need this dimension either, because we know we're going to get total width. And total width, this, think about the way we made this. We knew the center mark was this top left corner, and that's how we made this arc. So we don't need any dimensions to like edges of arcs. And so that's it for width. Height, working the same way. The first thing that happens is this edge right here, which we don't need because it's just the reciprocal of this one here. Okay, we don't need to dimension like edges of arcs, because they are already they already have a radius. So the only dimension we need is total height, which can go here on the front view, is fine. There we go. And this one only has one depth, total depth. And this is enough to make, or so I want to make this part. Actually, we don't need this one. And there you go. Center marks and arcs and radii, and then you go through our left to right every time something happens, take a dimension, mantras. Okay, save, yes to all, hit OK. And let's make a new sheet for come on now. You got this. There we go. Okay, new sheet. This is going to be part 10. And let's get a base view for part 10. And we'll go like this, this. Okay, we'll go to annotate and get center marks. And we'll center mark for there. Fantastic. And what do we need? That's the only center mark. Let's do our radius. Okay, dimension, click on the curved surface and try to get it to look like that instead of like that. I mean, it's not the end of the world. It still works, but you kind of have to move your cursor through the center line or center mark in order to get that. But there you go. And then with dimension, left to right every time something happens. We don't need to dimension to this point, okay? Because as long as we want anything to do with curved surfaces, we're worried about the location of the center mark. And in this case, we dimension from there to there. And the only other width is total width. And we can rearrange things a bit. I think that looks neat. Then height, there's only one height dimension we need, and that's total height. And there's only one width dimension, or excuse me, depth dimension that we need, and that's total depth. And there you go. Not that hard once you know the mantras or the process. Trust the process. I just say these are not that hard. It gets a little harder. And we are going to be looking for opportunities to use TYP in order to, you know, the reason why we don't overdimension is to limit the amount of unnecessary like lines or text on the sheet. You know, it doesn't help to have unnecessary stuff on there. The more complex you get, the more chance for confusion that you have. Let's go ahead and new sheet for, let's just rename the sheet as is. And a base view of, let's say, okay. And let's make sure we have enough room. Okay, so we have some enclosed curved surfaces now. So we are going to use the Centerline tool. Or they call it Centerline Bisector. And you have to think of, so this, using the center mark tool, if I click on this line right here, or this circle right here, it gives me a center mark. Imagine this center mark cross had a lot, was really like a stick that was pointing at you. If you were looking at that stick pointing at you from the top, you would be able to see it would look like that, okay? So this shape right here, looking at you, is just a point, but from the top, it's a line. Now, this shows you, or this shows the viewer, the reader, this line shows that the hole goes all the way through. If it was a partial hole that didn't go all the way through, you would see the dotted lines would sort of close off. The dotted lines would close off like that, and there wouldn't be anything up here. Okay, so that's what that information is giving you. This same hole from the right side, okay, just to see the click order is get the Centerline Bisector tool, which is this one right here. Click on one line and then click on the other line, and it produces that, and it sticks out like that. So you need to think about it that way. Now, let's get the rest of the center marks here. We want one here and one there. Okay. Anywhere a curved looks curved, we need one, and we also need one. Well, so this arc out here shares the same center point as this arc here. So it's not going to change this, but if we click on this outside one, it will extend it. And that shows that this center mark belongs to this arc as well as this arc. And we do need a centerline bisector for this to show that the hole goes all the way through. But we don't want one here, and that's because the centerline bisector needs to line up with the center mark. Okay, so this this center mark, if it was sticking all the way through, would make this line. And the same thing here, this center mark would make this line. These center marks would make lines here and here. They wouldn't make this one. So you don't put one there. As far as how you get that, how do you get that? Well, we're just going to ignore. We're not going to use this one right here because it's not, that's not a center line. I mean, it's the center between these two, but it's not relevant for us. Okay, so we have our center marks and our centerline bisectors that show it goes all the way through. And now let's do some arc dimensioning. And so we need a radius of 2 for that, for the outside. This will give us a diameter. There's our first diameter. And you can see the symbol for a diameter is the null symbol. And yes, this arc is larger than this circle. In fact, it's twice as large. And even though these are both 2, they are dimensioning different things. This arc is 2 inches from itself to the center. And because of this diameter, it's 2 inches all the way across. But you don't really need to know that because the computer does it for you. You just need to know where to put the lines. And remember the leader lines, which are the arc, the arrows for the arc. You know, this arrow line doesn't go straight up and down or straight horizontal. You got to have it at some sort of angle. And why not have them line up nice and neat? Okay. And the other arcs, we have another arc here. Dimension. There we go. And another arc here, which again, it's an arc, even though this sort of tablet-shaped or pill-shaped hole is enclosed. It's the arc surface, the curved surface isn't a circle, it's just an arc, so it automatically will give you the radius. And we can make this one, if you double click on that, you can type TYP, hit OK, let's see how that comes out. I don't know why, how did I get a box? What key is a box? And I guess we could put this on the same line. This highlighted thing is the actual text from the dimensioning. If we put TYP here, it's saying that both the arc it's pointing to and the one that looks very similar are actually the same. And so we don't need the other one there. We can't really count on this to be the same as that one. We can't really TYP. I mean, I guess you could, but it is a little bit, a bit of a stretch to have TYP refer to features that are on different views. And all right, so let's go ahead and dimension it left to right. From the left, the first thing that happens is the center point. And if we put it here, we'd be crossing some extension lines. We could put it here, and that's crossing onto the view. But if we put it here, we can just rearrange these guys to be there and there. And depending on where you grab the dimension, will change how it moves. So there we go. And actually, I'm not sure if this is solving it. Because I think that's fine. We know this is an arc, so we're there. And the next thing that happens left to right is the center point of this arc. So we'll go from the left to the center here. And the next thing that happens is the left to this center. And the only other dimension would be total width. And in this case, we don't need total width because we have, it's 9 from the left side. And then the arc is just this radius. So if you can ever infer a dimension, it's not necessary. I think that's enough for width. Can you make everything going? Oh, I do think we need to make this arc a center mark to extend it out. Uh, that tells you that the larger arc has the same center point as the smaller arc if you extend that out. Okay, so height. From the bottom up, the first thing that happens is a sledge. That's an easy one, same as before. The next thing that happens is the height of the center mark, which we could put here, and technically that's fine. I think that long extension lines are not ideal. So I would say, let's put it here. And once again, the total height is really just the height of the center point plus the arc, which we already know the arc. So we don't need total height in this case, which is strange. Normally we always need total height, width, and depth, but when it's really just a function of some other point plus an arc, well, there you go. And so then depth front to back. We need total depth, but, and I think that's it, because we know that the center mark for this is there. How can we do this? Do we need, I think it would add information if we had a distance from the center to there. But we're kind of already saying that, because this 2-inch radius, the center mark for this 2-inch radius, if we're already saying that it's 4 inches front to back, we don't need this one. And that's one less crossover. I'm not crazy about these lines crossing here, but you know, it's all about trade-offs. And if you don't have an option, this looks kind of crowded. Well, we can just put total depth over here on the right side view and problem solved. Okay, and there we go. We can make every aspect of this part with only those dimensions. Remember, the key is center marks and centerline bisectors. Radius and dimensions, like dimension the curved surfaces where they look curved. That's another thing. So the distance from this to this is this shape right here, or these lines right here are looking at the hole from the side. Okay, these hidden lines are the edges of the hole and the center of the hole. This is all the cutout. And technically, this dimension right here is the diameter of the circle. It's the height of the circle, but you always dimension curved features where they looked curved. Okay? This dimension right here doesn't, like, it's not super clear this is pointing to a diameter of a hole. Here, it's super clear it's pointing to a diameter of a hole, and that's what we're looking for. I think that's it for that one. Let's save it. And I think I want to get more than just 4 on this one. Maybe we'll do through 14. But either way, the next one is 12. And just like before, you got to trust the process. Mark those center marks. Well, first of all, save and new sheet. Right click, edit sheet, part 12. And base view. me any excuses. All right. So part 12, I still need to make part 13. I can fly through that. And let's do this. This is a weird shape in that this has a lot of curved surfaces, arcs across the top and the side, 3 different holes, 3 different big arcs, but none of the curved surfaces are on the front view. But I still think this front view tells you the most information of any one of the views. It has more contours. Think about contours, the perimeter of the shape. That's that shape, that's that shape. This goes in and all the way over. This one has the most contour, so it is probably the best front view, even though curves are a major part of this this part's reality. Either way, go to Annotate, center mark, and anything that's curved gets a okay. So here's an important thing to note. So if I get the center mark and I click on this outside larger arc, that's what the center mark looks like. But the center mark for the inner circle looks like this, and it looks very similar, but you got to click on both because this one, if I only click on the outside, I don't get that extra line right there. Or if I click on that one, it does. And that shows you that the center mark is the same for both, the same thing over here. And that's why you pretty much click on everything that's round when you're doing center marks. And I think that's it. Arcs and circles on both sides. Then centerline bisectors. Everywhere you're looking at a hole sideways gets a centerline bisector. First click is on this hidden line, second on this hidden line, and it gives you there. And that's not ideal that the lines all connect, but that's why we dimension to clear things up. From the front view, we have a hidden line that goes there, or excuse me, a centerline bisector that connects that to that. And what happens if you click on the center point? Now that works also. And then over here, from there to there. All right, so we have all our center marks. Now let's show how big the arcs are, or the curves are. On the top view, we have an outside radius, which is the same here and here. And anytime you're getting the exact same dimension on the same view, that's probably a good opportunity to do TYP. And if you double click on it, you can do capital TYP for typical. And same thing for the diameter here. TYP. Okay, so that takes care of those. And then we need the same thing over here. You know, I'm not really sure if I would consider does this TYP, obviously this TYP typical 2-inch diameter of this refers to this, but does it also refer across to here? Because this is a different view. Let's just be safe, have it extra. Okay, so that's every curved surface. Now let's do some dimensions. So width left to right, normally we'd start on the left edge and every time something happens, but this left edge is part of this arc, which is dimensioned already. So I would say our leftist edge is really just this center mark. And the first thing that happens is the distance to this inner part. And you could put it on the front view and do that, you know, debatable, but not both. I like dimensioning to the center mark rather than to this centerline bisector. And then same thing again, distance from here to the other side. And let's give ourselves a little more space. And distance from here to the other center mark. Nope, not like that. Not like that, not like this. And there you go for that. Okay, all of the features left to right are taken care of. The only parts we don't have with linear dimensions for are from these center points outward, which is taken care of by the radius. Okay, then height down to up. We definitely need the distance from the bottom to this first ledge. Then we need the distance from the bottom to the center mark, because that's what this outer edge is based off of. But just like before, I think it probably looks better here because it's actually dimensioning to the center mark. So there's that. And the only other, and that takes care of total height because it's this plus that, just like it was before. Then we only have depth, which, I mean, it's kind of already, you can kind of already infer it by a 2-inch radius arc that covers it. But I think we should probably also do depth front to back, which either needs to go here or here. Although, yeah, like I said, it's already, we already have this information. Yeah, anytime you have like that's, it's saying the same thing. So I don't think we even need it. Our depth dimensions are handled by these arcs. And I think that's it. Let's save it. Yes to all. Okay. And some redundant practice, I guess. What I don't think I have 13 yet. Or I haven't saved it. Let me go ahead and make 13 real quick. And what does 13 look like? 13 is, let's put it over here so I can see it. 2, 4, 5, 6, 7. We'll go 7 by 2 and extrude it 4. Actually, let's make this 9, and then we'll just fill it off the edges. And we'll go fillet this edge and this edge. The radius of 2. Yes. Take this. Yep. And go like this. And we have a 2-inch circle here. And we have another 2-inch circle. Can't see the snaps, but whatever, we'll just go like this. And distance from here to the edge should also be 2, and the distance from here to the center point is 3. And we can extrude these. And over here, we can have a rectangle to make the tower part, which needs to be 2 this way. And let's extrude it, the total height, which is 1, 2, 3 to there, 5 tall, or 5 above where we are. And then we have this lower arc, which is centered. It's an arc, but I'm going to use a circle to make it. That's another 2 if we're doing that. The distance from here to the bottom is 3. And Then we just have our rectangle cleared out that way. And extrude. Switch it to cut. And then we just have one, but a radius of 1. They do not share the center point. I think that's right. Is that right? 1, 2, 3. Okay. So let's go ahead and save this part. $13. Okay, and so let's go ahead and add a sheet. Place fuse, a new sheet. Base view. Okay, 13 and 14, I think also are very similar to the ones where they have arcs and circles and whatnot. So what's our pattern? Our pattern is center marks, centerline bisectors, dimension, radius and diameters, and then, and only then do we do our width, height, and depth. So center marks, everything that's curved gets our center mark. Boom, boom, boom. Over here, we got that. And these arcs also. And I think those are all of the curves. This looks strange, but it is what it is. And there's that. Okay, centerline bisectors. Where do holes go all the way through? This one and this one. Okay, this is adding a lot of information that these are both complete holes that go all the way through. And there's that one. You don't get one for the arcs. It's only for full circles. There we go. And let's do some radii and diameters. Okay, up here we have a radius. There we go. And just to switch it up, let's dimension this one. Okay, and we don't need this one also. We can just do our TYP for this one because they are the same. Are there any other curved surfaces here? There are not. Okay, over here, this is clearly a curved surface and it's the same as this one. So we can do TYP on this. And we have another curved surface here. I think that's all of the curved surfaces. Lovely. Okay, so now we get to do our left to right. Every time something happens, take a dimension. First thing that happens from left to the right is the distance to that. It's the width of the tower part. So that's good. And then the next thing that happens is the distance from the left to the center mark, which it's always good to dimension circles and arcs. Again, we need size and location. Size is they're either radius or diameter, and location is distance from another known point, like the left side. Okay, and we do want to dimension to that center mark rather than to the centerline bisector because, you know, centerline bisector is by definition a hidden line. Okay. And then same thing for the center of the next hole, distance from the left side to there. And the only other width is total width, but that's handled by the 7 plus our radius of 2. And that handles width. Okay. Height down to up. First thing that happens is that. Beautiful. Can't beat that. The next thing that happens is the center mark for this arc. Distance from the bottom to the center mark. And this is getting kind of crowded. You could extend this out, but I'm just going to move this guy over to here. If you still have dimension tool on and try to move something, it will bring up the edit dimension box. So you need to hit escape or right click OK or right click escape to move things. But I'm going to put this over here just to kind of give it some space. Then we can't count on this height plus this. Nothing on here shows the distance, the location of the center point. So we need it. Distance from the bottom to the center point of the small fillet. And total height is handled by that 6 plus the radius of the arc. And there's that. And then depth front to back, I believe we are handled by this radius being 2 and a full semicircle. Tells you the depth is 4. And this circle sharing the center mark tells you that it's centered left to right, or centered front to back. And that gives you enough to make this, which is the point, so to speak. And you can start to see how once you start putting radii and dimensions, radii and diameters on there, it starts to get a little more crowded, and your neatness skills become much more important. And let's add another sheet. I think we can stop at 14 for today. And so we need to edit sheet, and we'll call this part 14. Let's do a base view. Part number 14. Do I have the rest? 15, 16, 17, 18, 19, 20. And again, make sure you're doing yours full scale, 1:1, so it fills the sheet comfortably. But I'm doing this. I wonder if, is 0.5 still good? Give me a second. I want to see, do the dimensions. I'm going to go back just so that you can actually see the numbers. All right, so let's center marks. Okay, you get a center mark, you get a center mark, everyone gets a center mark. And those are all the curved surfaces. There are no curved edges on the front or right view. Centerline bisector. First one is here. No, that's not it. That's, what is this, center line? I guess you could do center line as like that. We're not going to do that. But we do want centerline bisector for holes that go all the way through. This is a hole that goes all the way through. There's one, and looking at that from the other side is this one. And there you go. Okay, let's dimension the curved surfaces. We need a dimension there and a dimension there. And these look like the same things from the top. Okay, if you were to draw a shape all the way around, the left and right side look identical. But from the left side, it's dimensioning in a complete circle, which is why it gets diameter 4. And the right side is just an arc. This isn't a complete circle, which is why it gets radius 2. Which is pretty much what we've been doing the whole time. But either way, we've got that's one. There you go. And this is again a radius, and this does have an identical arc. So let's go ahead and give this one a TYP. But I think that's the only one that gets that TYP. And those are all the curved surfaces. Let's make it look pretty. I don't know. If you like this sort of everything spread out kind of look, I guess. I think things sort of stacked looks a little better, but I won't take points off for style, you know, as long as it works. Those are all the curved surfaces. So let's do our width, height, and depth. Okay. We don't need to work all the way to the left because we have a center mark here. This can be our sort of origin points that everything is dimensioned off of. And we don't need anything to do with this because this 4 is really just the diameter of this circle. And so we don't need it. We're still using this as our sort of origin, which up until now, with all our parts that only had straight lines, we've just been using the farthest left part of the part as our origin. But we're not doing that now that we have, if you have a curved surface over here, it's wherever that center point is going to be our origin. So the first thing that happens is this center point. Going back to our origin, the next thing that happens is this center point. And you don't need to dimension the distance between these because you can infer it based on 8 minus 4. And that's it for width. Height, down to up. First thing that happens is the height of this ledge. Perfect. And the only other height is total height. And that could go there or there. Either is fine. I don't know. I like shorter extension lines, but I also like them next to each other. Neither of these is technically wrong. So that's height. And the only other direction, the only other dimension that we need to dimension the dimensions for is total depth and our radius 2. Oh, wait, I didn't get a center mark for this farthest outside. Okay, you can see that adds these little, there's a word for it. It's not a, I think it might still be an extension line or center mark line extending out to, you can see what happens, what changes when I click on the edge. What changes is those lines go out. That's saying that arc owns the center mark the same that this one does. If, let's see if I can change this slightly. Let's open up this part. And I actually can't change this easily at all. Never mind. If they had a slightly different center mark, because when I made it, I was clicking on center marks. It will be always constrained there. So things never go well when I try to break things on purpose. They end up not breaking. Okay, but that's it for part 14. And you need to get these done. We're running out of time. That's not what we're looking for. We are looking for this and this. Okay, this is actually part right here will be 9, 10, no, not that. 9 through 14 is what that's going to be. And when the video goes up, it'll be right there. And like I said, this is the end of the quarter. We will do, I'll do parts 15, 16, 15, all the way through 20 in 6th period today. And so those videos will be up, and that's going to be the end of the assignments. You need to get them done. They aren't going away. Okay, let me know if you have any questions. Before we sign off, just give me a second here. Make sure, okay, this is the thing that's going to add the most work for you if you don't do it, is not having a single drawing file with all of the different sheets in it. If you're still making new drawing files for each different part, you are adding so much work to your life. So there's that. Also, I would say go back and change all of the views to be shaded, which is just this one. And you got to do it for the orthographic ones, which are the front, top, side, as well as for the isometric ones. I think that looks a lot better. Okay, like I said, if you have any questions, let me know. Let's get it done.